and variables. This is chapter 15. We are going to discuss today combining data from X, data from Y to find the expected value and the standard deviation. Okay, so step one, go ahead and look at your formula chart. And on your formula chart, I want you to fill out the mean of X, the mean of right here. And that's on your formula chart. The standard deviation, which is right here. And then also here, I'm going to change this as well. This is correct. This is not incorrect. But I want you to notice the variance is standard deviation squared. But that's just basically this formula without the square root, right? It's all my x's minus my mean squared times the probabilities. So it's the same thing, and I just want you to notate this because we're going to talk about it later, but basically here you can see that these formulas are identical, except the standard deviation has the square root. All right, so we're going to start this, and basically what it says is you have, you're working at a place, and you get paid either $9, $12, or $15 an hour. But the boss has decided to give you a raise, which is either $1 or $3 an hour. So first of all, the first step is to find the mean, standard deviation, and variance of your pay, and then the mean, standard deviation, and variance of your bonus. So the first thing that I did is I went ahead and put in the calculator. I'm just going to put the first one in the calculator for you so you can, just in case you don't remember how to do it. So let's open up our calculator. So I'll go back to our CAS. And you're going to add a listen spreadsheet. And so I'm going to put here, you got to label it. So I'm just going to put pay for my salary. And then the pay that we got was $9, $12, or $15 an hour. And then the amount, so the probability, I'll just put PRR. And that was, let's remember, that was 30, 45, and 25. So I'm going to put 0.3, 0.45, and 0.25. Okay, so now we're going to go ahead and do a one variable statistics, which is menu, stat, which is 4, 1, which is stat calc, 1, which is one variable statistics. Just hit OK. We're doing one list because it's just about the pay. The second list is the probability about the pay. So it's just, we're talking about one thing and we're doing one list. So you're going to do drop down menu on the X list, and that is going to be pay. And then don't forget the frequency list. If you don't do the frequency list, it averages the 9, 12, and 15. So the frequency list is my PRR. I hit OK, and there we go. My mean is $11.85 right here. And my standard deviation is right here of 2.22. So I'm going to go ahead and put that here. And I got my mean at $11.85, my standard deviation at $2.22, and I square that to get my variance of $4.93. Now let me remind you, as far as on the test, you would write the probability, or the X value times its probability plus ... X value times its probability, so to show that it's going from the first value to the last value and all the values in between. So you have to make sure you show work, and make sure you put dollars. If it's dollars, I mean, whatever it is, whatever the units are, and then write the answer. Okay, so I'm not going to show you again, but you're going to do the same thing for this. You're going to make a chart, and you're going to go ahead and put it into my work. All right, it says let N be the new hourly wage. So I'm going to add these together. And first of all, it says are X and Y independent, why or why not? Well, if you look up here, it says assume X and Y are independent. So yes, they're independent because it's stated in the problem. That's all you have to say. The reason I wanted to reiterate this is that I want to make sure you understand you can never assume independence. It has to state it in the problem unless it's a universal event that is always independent, such as rolling a dice. Rolling a dice, shake it, roll it, shake it, roll it, shake it, roll it. It's always, each roll is independent from the next. Each roll has no influence on the next roll. So this scenario that we're having with the pay may or may not be independent as far as every time, because let's say I have this worker who works for 5 years and this worker who's worked for me for 1 day. So I'm probably going to want to give the 5-year worker a lot better bonus or raise than the 1-day worker, right? So in that case, it would be dependent. Versus if I just had a big bag and I say, okay, everybody, I'm putting in here 70 cards that have $1 on them and 30 cards that have $3 on them. Go ahead, I'm going to shake them up, and then you pick it out, and then that's your new raise. Well, that would be independent. So there are ways to do independent and dependent for this one, so it's not globally independent. So you would have to make sure that you would state that in the problem itself it's independent. If it's not stated that way, you cannot assume that at all. And the importance is because you're about to use these different equations. So I stated here on the equations that either probability of A over and B is equal to probability A times B, because the overlap is equal to the product. Remember that little song? Right, the overlap is equal to the product. And also I have given A given B is equal to A given not B, and then which is equal to A. Now that's true only when it's independent. However, I don't need that particular one in here. So the yellow one that I circled is the one that I'm going to need for this problem, because it says what's the probability of getting $9 and $1. So that's going to be $9 here. I'm just going to, let me get rid of some of this. Yeah, so the probability of $9 is 30%. The probability of $1 is 70%. And so that's going to be 30% times 70%, which is 21%. Okay, the next part we do is we're going to complete the table for the probability x plus y. So I'm literally going to take all of my x's and I'm going to add them to all of my y's, the combinations. So I showed you how to do the combinations up here, 9 plus 1, 9 plus 3, 12 plus, and so forth and so on. And then, of course, I showed you how to do the probabilities by multiplying each one down here. And I put the actual answers in the n and the probability. So, though if I'm going to show work, I'm going to show work here. I'm going to have each one, again, times its own probability. You see that? And then I just did plus dot, dot, dot. And I put the first one and the last one, and then the answer. So I got $13.45 and $2.40. I did add a third decimal on this one just because it'll help you see something later on. Usually 2 decimals is fine, but I'm just doing it specifically because I want you to see something later on. Okay, so then done with that. The next one says, okay, let's look at scenario 2. Scenario 2 is, your boss says, hey, instead of me giving you a pay raise, I'm so sorry, but looks like our company's under hard times. I'm going to either have to do layoffs or pay cuts. So you guys get together as a company and decide, you know what, we're going to do a pay cut so we won't have to lay off anyone. So everyone takes a little bit of a pay cut, but it's going to be the same probabilities as far as this still your base. The $9, this one here is still your base, and this is still the amount that's going to either going to get lower, either by $1 or $3 an hour. So that's why I say, what's the probability of getting 9 and 1? It's the same probability as we had above here. Same thing. And you can see I just did all the combinations of 9 minus 3 all the way to 15 minus 1 to get my values that it could be. And I did the same thing. I just multiplied the $9 an hour and the $3 for the deficit. And I put it into my calculator, the same thing, the menu 411, and I got $10.25. The same thing here and the same thing here. All right, so now that's just kind of all the calculations. You really haven't been thinking. You've just been kind of just boom, 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 putting in formulas and calculators. So now I want you to just put everything into this chart. So what I've done is I've taken, okay, the mean of X was 1185. How did I get that? I went up here, mean of X is 1185, okay? Mean of Y is 160, so I'm going to put it down here at 160. And so forth and so on. So now I want you to tell me, how is the mean of X and the mean of Y related to N, which is adding the two data sets together? Well, last time I checked, 1185 plus 160, gives me 5, 4, carry the 1, there we go, 1345, ding, ding, ding. So I can write a formula of the mean of X plus the mean of Y. Because remember, this was my 1385, or 1185, sorry. And this was my 160, remember? And this, of course, was the total of 1345. All right, so the same thing for 1185 minus 160. And that's going to get me 1025. So that's the mean of x minus the mean of y. Okay, so what I've noticed so far is that the means, it's easy. I add those, I add the means. I go, okay, this is mean of x plus mean of y. And this is mean of x minus mean of y. Okay, let's see if it has the same pattern for standard deviation. So standard deviation, 2.22. 2.22 plus 0.92 is going to be 4, and that's going to be 1, carry the 1, 3.14. Oh, and it is definitely not that. Well, the only thing I notice is that adding or subtracting gets me the same, but I don't really know how to do that, so I'm just going to skip it and put it aside for a second. Because I did notice that my variance of 4.93 and 0.84 is going to be 7 carry the 1, 5.77. And oh, I see that it is my variance, so that's my variance, which is, my variance is this symbol. That's this symbol. And this is this symbol. That equals the 5.77, which is the n. But it also is equal to the m. So what this is telling me is that, remember, if my data is here and I shift it to the right where I add x plus y, I shift it to the right. If I subtract x minus y, you can see that the length is the same. The standard deviation, the distance is the same. So that's why it's 5.77 and 5.77. All right, so you can see I have, for the variance, I just add both variances together. Simple, easy. Remember, we kind of got stuck on standard deviation, didn't know how to do standard deviation, but we did on variance. Well, let's go back to this formula that you wrote in the very beginning of class. And the very beginning class was this one. I asked you what the variance was, and we decided that the variance was the same as the standard deviation, except standard deviation had a square root symbol. So all I have to do is take this and put a square root symbol on it, and that's going to be my standard deviation. Try it. The square root of 5.77, yep, indeed, the square root of 5.77 is indeed 4.402, 2.402. Okay? The reason this works this way is because if I have a standard deviation of 2 plus a standard deviation of 3, you can't add this. You can't just say, oh yeah, that's the standard deviation, that's that. And no, it's not. You can't just add that. So standard deviations work like square roots where you can't just add them, but you can square them first, right? And then add them. And then you're able to add them. This only works if x and y are independent. The reason only works if they're independent, because remember, how did we get these probabilities in the first place? How did we get them in the first place? We multiplied them. And in order for them to be multiplied, they had to be independent. So for the notes, this is just the same thing that I just showed you, combining random variables. There's your two equations for the mean, and there's your two equations for standard deviation. Remember, you add variances, not standard deviation. The other thing to make sure you note, and this is the biggest thing people mess up with, oh, look at that. Oh, my goodness. How did speaking of mess up, wow, that's going to be added. All right. Okay, so, and that's what I was going to highlight right there is that people mess up with that, and I surely did when I made the notes. So that has to remember, because standard deviation is average distance from the mean. Average distance from the mean is a distance, and so it never can be subtracted because that's going to potentially give me a negative, which would be a negative square root, which would be an irrational number, and it's a distance, so it's not irrational and it's not negative. Normal distribution calculations. So this is a reminder. So I've done that. This is, take way back for like 2 months ago. Normal distribution calculations. So I'm going to combine what we just learned today with something that we did 2 months ago with this normal distribution. So with normal distributions, first of all, you're going to use the formulas that we just did to find the mean and standard deviation, and then you're going to proceed as usual. So, for instance, if this here is my normal model, you would use normal CDF or inverse norm or Z to be able to find the values. So let's go ahead and look for the check for understanding and solve that. So here we have this first one, and it says what's mu D. So to find mu D, it tells me mu D, basically I have to subtract X and Y. Okay, so it gives me mu X and mu Y. So this one here is X, it didn't, and this one here is Y. So I find 22.98 minus 20.9, and that's 2.8, okay? And it means if we were to choose many, many NFL games, the average difference in points for home versus away teams is 2.08 points on average. Now, calculate sigma D. Remember, sigma D, I cannot, it's going to be square root of X plus Y. And so I just look at X and I look at Y, square both, and there we go, and I get 13.32. Okay, the last thing it asks me to do, it says, okay, what's the probability that home is bigger than away? Well, home bigger than away is basically saying, okay, home minus away, if that's bigger than 0, then that means home scored more than away did, okay? So I'm going to create a model where it tells me the mean. We figured the mean in part A was 2.08. We found the standard deviation in part B was 13.23. And then I'm going to do a model. So here's my model. And I'm looking for the probability that this is bigger than 0, because bigger than 0 represents when home scored more points than away. So when I do normal CDF, you throw it in your calculator. Remember, normal CDF, you put lower bound 0, upper bound infinity, mean 2.08, and standard deviation 13.23. You actually get 56.25%. And so I have about a 56.25% that the home team scores more points. All right, I hope that helped, and continue to work hard on this, and let me know if you have any questions. Thank you.